Hi everyone, today we are comparing fractions using Equati0. Our learning goal is we are learning to compare fractions using fraction strips and by finding a common denominator. So I wanted to review quickly that comparing fractions with a common denominator is relatively easy. We know that you're just talking about which one has more pieces that are the same size. For a common numerator, we know you have the same number of pieces, but they're cut into different sizes. Pizzas cut into eighths will have smaller pieces than pieces cut into fifths. So relatively easy to compare. 4 small pieces is going to be less than 4 bigger pieces. Comparing to a half is another good strategy to use. When we're given two numbers like 3/5 compared to 4/8, we can think about them in comparison to a half. We know that 4/8 is a half, and we can figure out that 3/5 is greater than the half. As long as we know what half of 5 is, or 2.5, we know 3 is more than that. So comparing to a half is another good strategy to use when both the numerator and denominators are different. Where we might get stuck is comparing fractions that don't have a numerator or a denominator in common and are both greater than or both less than a half. So the examples of 5/8 compared to 7/12 or 2/9 compared to 1/3 would be good examples that we need to do a little more work on. So we're going to work on those ones today, and we're going to use 5/8 compared to 7/12 as our example today. I'm going to be asking you to show me a few different ways to compare these fractions, and we're going to start with the area model using fraction strips. So to start today, we're going to insert our math space, and we are going to create fraction strips showing 5/8 and 7/12. So our first one here is going to be our 5/8. So eighths means we have 8 segments. 5 of those segments are shaded. Again, we want to use the same size hole, so let's copy and paste that one and line it up underneath to help us compare. And this one is going to be our 7/12. So it's going to have 12 segments, and 7 of those segments are going to be shaded. And it's going to give us a nice visual to show us which fraction is a little bit bigger. So creating my labels here, 5/8, I'll insert that math and bring my label over, is just a tiny bit larger than 7/12, and insert that as well. So that's our area model. That's what I need you to do, and you're now able to just see visually that 5/8 is a little bit bigger. Let's insert that into our space and move on to the linear model. So we are going to go back into a new math space to create our number lines to show this. Let's start by just writing out those fractions again. 5/8 for the first one, and 7/12 for the next one. And we'll just move those over here. Excellent. Let's create our number lines next. So our first number line, we want to show 5/8. So here's my number line. Giving me a bit of a hard time. Let's delete that one and try one more time. There we go. Let's show this one broken up into those 8 segments. And let's create our number line that shows 12ths while we're here. So actually, we're not going to create a new one. We're just going to take the same one to keep it the same length, the same size hole. We're going to copy and paste that one on there as well. But this one, we're going to switch to be broken up into 12ths. Now, next, we're just going to go down here to our other set of tools, and we're going to see how much of that line is shaded in. So let's grab another line. We're going to start it right at our 0, and we are going to go up 1, 2, 3, 4, 5 eighths here, and stop right in the middle. Sometimes the color gives me a little bit of a hard time. Let's see if it's going to do that today. There we go. We will make it blue. And let's add another line at the bottom to show our 7/12. So did I grab a line? Let's make sure. There it is. We'll start at the 0 again and go up 1, 2, 3, 4, 5, 6, 7. And now we're able to compare those two line lengths and again see that 7/12 is shorter than 5/8 and is therefore smaller. Let's insert those into our workspace and move on to the last way to find or to compare fractions. So the last way we're going to do it is by finding a common denominator. So let's go back into our math space. And we are this time going to write those fractions down again. 5/8, and I'm just going to leave some space here to help us compare that to 7/12. Insert that into our math space. Now, we are really good now at finding equivalent fractions after all the work in the last couple of days. So what we are going to do is find equivalent fractions for 5/8 and 7/12 until we find one that has a common denominator. Now, if I increase by 12 each time, I'm going to get 12. I can write these out for you. Then 24, then 48, and 56. And I could go on from there. Let's insert that in just so we have them on the side here. So those are our multiples of 12. Let's also add in then our multiples of 8 to see if we can find a common number that will work for both of these. So 8 and 16, 24, 32, 40, 48. Look at that. I found one in common. So let's stop there. Insert that math so you can see them. Okay. So we can see that we finally found the number 48 in common. And by finding the number 48 in common, it means that both of these are able to have equivalent fractions with a denominator of 48. So let's write that 48 on there as a denominator because we know we can rewrite 7/12 as an equivalent fraction out of 48. There we go. We also know that we can write 5/8 as an equivalent fraction with a denominator of 48. So let's go ahead and do that. We remember that whatever we do to the bottom, we're going to do to the top. So down here, to get from 12 to 48, we multiplied by 4. We are going to do that same step at the top up here, and we are also going to multiply 7 times 4. So 7 times 4 is 28. 28. Ooh, it doesn't like when I do 8s like that, but good enough. Now on the other side, 8 times what equals 48? So we had to do 8 times 6 to get 48. We're going to do the same thing to the top. 5 also times 6. And 5 times 6 equals 30. Now that we've done this, we can see our new equivalent fractions that we are also able to compare. So our new equivalent fractions will show us that 30 over 48 is going to be compared to 28 over 48. And it becomes very obvious which one is greater than. So 30/48 is greater than 28/48. Therefore, 5/8 is greater than 7/12. I'm going to insert that math down here to show my final answer and insert that into our math space. Just going to delete what I had there and push this over and shrink it a little bit. And we are done. It's your turn. I have asked you to choose two fractions that are both less than a half and do not have common numerators or common denominators. You're welcome to use the numbers 2/9 and 1/3 like I did back here, but you don't have to use those. You can choose your own. Give it a try. Come up with your models. Do all three ways. And then today, to finish off, I have a fraction war game comparing fractions. Enjoy the rest of your day, and I can't wait to see you tomorrow on our game show.